If I was going to pick a lesson in chapter 5 that I was going to say is the most important, it's probably this one. All right, dividing polynomials. It gets used. We go from this one, and then we take this lesson, and then in lessons later on we apply it. Okay, so we're going to take what we learned today. We're going to kind of use it. It needs to get done. It's a process. We're going to take it later on and keep going with it. Okay, so today's pretty basic examples, and then later on we're going to apply it. All right, it's going to start off like this, where you have a polynomial. Okay, see how there's three terms here? Over a monomial. Okay, so there's two types of problems today. This is the first one, where you have a polynomial over a monomial. All right, and to take care of this is pretty simple. You just split it up into three. And then each time you're going to put it underneath 3xy. Okay, split it from one fraction to three fractions. And then you're just going to reduce it like you did yesterday. Okay, or like we have been doing. So you're basically turning one problem into three problems, and that's it. And you're just putting signs in between. Okay, so you have 6x to the fourth y cubed over 3xy. So 6 over 3 gives you 2. X to the fourth over x gives you x to the third. Y to the third over y gives you y to the second. All right. Your next sign is plus. What's that?
So on the homework, I know there was some you would get a negative exponent. Is that how do you fix that?
Same way. You would just move it down. Okay. But simplify these first. Okay. Like if say this was negative 3 here. Simplify it first and then move it down after. Okay.
Where?
Like you would, since it would be negative up here, move it down to the denominator.
Well, no, like the exponent on that x would be 3, and the exponent on like this x would be 5. So the bottom x, so it would be negative 2, and then
just subtract them here and then move it down. Just like you did. Nothing changes. Okay. So then 12 over 3 gives you 4. X cubed over x gives you x squared. Y squared over y gives you y. Minus 18 over 3 gives you 6. X squared over x gives you. And the y is what? Y's cancel. So they're down to 1, so you're good. What's your answer? Now, there can be, basically, you guys will see, since I'm going to keep this section as worksheets for you guys, you'll see two different setups to it. Yeah. The first setup is the one where it's already a fraction. The second one is when you actually have to divide sign in it. Okay, we're going to work with this a little bit later on today also. So you set it up the exact same way. Okay, you just take the 3xy and you put it underneath each term and then simplify. So 18x squared y over 3xy. And then you just simplify again. So 18x squared y over 3xy goes to 6x plus 9, what, x squared yz. Okay, now notice though this one's different. Here you have a polynomial. But now we're dividing by binomial. See the subtraction sign here? Okay, so that's what makes this different because it's not just one term, it's actually two. So this is a binomial that we're dividing by in this case. To do this, we're going to do a little shortcut. Alright, so this isn't going to show you everything that's going on with the problem itself. So some things you're just going to have to roll with and we'll go back and get a deeper understanding. Okay? Before you guys do this, I want you to do this first. I want you guys to take 108 and divide it by 2. Long. Okay. All or actually, hold up, not yet. I don't want you to do that yet. Hold on, sorry. 54 is the answer, but hold on. I want you to do this instead. I want you to do 2x cubed divided by x. What's that? 2x to the second. Okay, keep that in mind whenever I start this. All right? I'm a little out of it today, in case you guys can't tell. Okay? So, this is going to be a process and a procedure that you guys need to learn how to do. Okay, it's not a hard procedure. There's a little bit of setup though, okay? The first part of the setup is this. You're going to take the numbers that you see in front of all the x cubes and the x squares and write them in a line. Okay, write them in one line of your notebook. Alright. You're going to leave like a notebook line's worth of space here underneath them because you're going to put numbers down here too eventually. Okay, and then after that you're going to put like a long equal bar. Like that. Okay, everybody good so far? Okay. Now off to the left hand side we're going to put a little half box. I don't know why it's a half box, not a full box, but whatever. And then we're going to take this number here, okay? But we're not going to take it. We're going to take its opposite. Okay, so what's the opposite of negative 4? 4. So it's going here in this box. Okay, everybody good? That's your setup that's the process to your setup to do this. All right? So that's the first thing you have to learn. Okay, you take your coefficients, you write them in a line, okay, going from the biggest exponent down, all right? You take the opposite of what's in the binomial, and then you put it off to the left-hand side in that little half box. Sure. If it makes your heart warm, sure. No problem. Okay? Now, the next pen stroke I'm about to show you is the most important pen stroke in the entire thing. Ready? Everybody focused. Everybody watching? Everybody ready?
Oh my. So it changes something.
No. What's an arrow mean? Probably. Bring it down. So you bring 2 down. Okay, you do that first. Okay, you bring 2 down.
They all don't go down?
Not yet, no. Okay? You're just 2. Just 2. Okay? Your first number that will always go straight down. Okay? Because look up here. Remember this? Not a coincidence. Okay, see that? Alright. Now, here's where the process begins. Every time you bring a number down, you're going to multiply it with negative 4, or positive 4, sorry. Okay? So what's 2 times 4? 8.
You change the 2 to an 8?
Nope, it goes underneath negative 13. Because the arrow took the place underneath too, see that? So you can't put 8 here, so you got to put it underneath here. Okay? Now, here, we're going to ADD. So what's negative 13 plus 8? Negative 5. Okay. Now, see how we just brought negative 5 down below the line? So now it's in this line. So we're going to take negative 5 and multiply it by 4, which would be negative 20. And it's going to go underneath the 26. You're going to add those up to give you 6. Okay. You're going to take 6 times 4 to give you 24. Add it to negative 24, which gives you 0. Okay. Everybody good? Now, the last number has a special name. Does anybody know? Take a guess what it might be? Starts with an R. Nope.
Have we heard it before?
You have. Many of time. You got to think back, though. You got to think to your childhood days with the divisions.
Real number.
No. Remainder. Remainder. The 0 is your remainder. Okay, now, when you get a remainder of 0, like just in numbers, okay, so like when we did 108 divided by 2, we got 54. We got a remainder of 0, which told us that 2 did what to 108? Divided it evenly, okay? So since we got a 0 here as our remainder, we know that x minus 4 divides into this guy evenly. So we don't have to worry about our remainder, but we do have to write our new polynomial, okay? And this is how you do it. See how these numbers came from here? So now you put these numbers back into a polynomial. And if it's going to have a polynomial, it's going to mean what? You have x's. All right? But remember how I said this is a shortcut. This isn't everything going on. There's some behind-the-scenes stuff, and one of the behind-the-scenes things is this right here. Okay? Behind the scenes, you took 2x cubed and divided by this x right here and got 2x squared. Okay? Everybody see that? So, see how you had 2x cubed here on your first one. So now this one, that first term it's going to be is 2x squared. Okay, you go down 1 from what you started with.
Okay, so it'll be negative 5x.
And then
6.
plus 6. And that's your answer. Alright, they don't necessarily have to be, cubes. They can be whatever size they need to be. Alright, so here we have an x squared. Okay, so what's the coefficient on the x squared? 1. Okay, so you got to know that. Alright, then 3. Then negative 40. Okay, since this is negative 5, what goes here? Positive 5.
Oh, so usually the opposite.
Opposite. Always the opposite. Yep. Alright. Bring the 1 down. Then what do? Multiply that by 5 to give you 5, and then you add with 3 to give you 8, and then you multiply it by 5 to give you 40, then you and then you add it to get 0, and that is your remainder. Okay, notice I always box my remainder. Okay, I always do that, just so I know where it's at. That way it doesn't become part of my answer, okay? It shouldn't become part of your answer unless you have one, and we'll deal with that later. Okay, but we started with x squared, so what goes with 1? Just x, and then you have a plus 8. Okay, not bad. It's the same process no matter how big or how small. I could give you x to the 12th if I really wanted to. Okay, then you would just have 13 numbers through here. I mean, it'd be a lot, yeah, but it's doable. Okay, all you're doing is multiplying and adding. It's just when do you do what. Make sense? Okay, I want you guys to do this one here. Okay, now, you bring a number down, you multiply by what's in your box. So 3 times 2 gives you 6. You put it underneath the next slot. Negative 8 plus 6 gives you negative 2. Negative 2 times 2 gives you put it underneath the next spot. Okay, that's why this arrow right here is important, okay? Some people won't write this arrow. Those people like to live dangerously. Okay? Because they'll just do 3 times 2 and then they'll get 6. And you know where they'll put 6? Right there. And then they'll add it to 3 and they'll put 9 here. Oh boy, are their numbers wrong after that. Okay? So this arrow does twofold. It reminds you your first step is to bring the 3 down. it also blocks you from putting any number here. Okay, so make sure, it seems childish, but make sure you put that arrow in. Okay, I do it. I do it to this day. Just working a problem by myself, I'll do this. Okay? So 11 minus 4 gives you 7. What's 7 times 2? 14. Well, this one didn't work out like I thought it did.
So, shoot. Huh? So you subtract them, right?
3x squared minus 2x plus 7. I want you guys to get good at this. I want you guys to be able to go through these fairly quickly, but also at the same time, don't rush. Because when you rush, you make stupid mistakes. Okay, silly mistakes like that. Alright, and this is something that needs to get pretty good understanding of, pretty well mastered. Okay, Stover, what's up?
The x squared.
Here?
Yeah.
Mm-hmm.
Why is it squared?
See how you start with cubed?
Yeah.
And we're dividing by an x here, see that?
Okay.
So x cubed divided by x gives you x squared. So that's why this goes down to x squared. Behind the scenes, remember, this is a shortcut. Okay?
So it's all. So like all x cubed, you're gonna go down to x squared. Okay.
Okay. Yeah, we got 2 more. Okay, and these are going to be your 2 differences. All right, your 2 different cases. The first one being a squared plus 7a minus 11 divided by a plus 3. So we got 1, 7, negative 11, and in our box goes what?
3.
Nope. Opposite, negative 3. Okay, always the opposite of what's in the binomial. Okay, opposite of that guy. Bring the 1 down. 1 times negative 3 gives us what? Negative 3. 7 minus 3 gives us 4. 4 times negative 3 gives us negative 12. Negative 11 minus 12 gives us
21. 22.
negative 22. Oh boy. Or it's negative 23, yeah. Anyways,
Sorry.
I said I'm out of it today. And that number's called your what? Your remainder, okay? Now, think back. Okay? Whenever we did long division, like let's say it was, I don't know, keep it simple, 29 divided by 2. 2 goes into 2 how many times? 1. 1 times 2 is 2. You subtract it down, you get 0. You bring down the 9. 2 goes into 9 how many times? 4. 4 times 2 gives you 8. Minus gives you 1. That 1 is your remainder, right? Okay? And there were basically 2 ways you guys were taught how to write remainders. One of them was the easy one, which is called a what? Which was with a R. Okay? 14, R1. That was like 2nd grade. No, we're not going back to 2nd grade. Okay? Sorry. What was the other way? Does anybody know? Pusa? Okay, Sydney? Okay, you could get the decimal number, but where do decimal numbers come from? What F word? I got you guys tracked. What F word do decimals come from? Xavier? Fractions. And how did you write this fraction? You wrote it as the remainder over what? The remainder over what you divided by. Okay? So you're going to do the same thing here. Alright? So, a squared starts, so you go a plus 4. Since it's a minus 23, your next sign is a minus.
Since
Nope, just 4.
4a.
Just 4.
Why?
Because you start with a squared up here on top, right?
Okay.
So you go down to a, and
Okay.
then you know out it. Okay. You got a 23 as your remainder, and you divide it by what? Originally.
-3.
Originally,
1.
without the shortcut.
A. Excellent. X plus minus 3.
A plus 3.
A plus 3.
The whole thing. You originally divide by. From the original. Okay, that's how you handle the remainder. Okay. Now, if your remainder ended up positive, this sign would be what? Plus. Okay? That's the only difference. Okay, we have 4a to the 4th plus 2a squared minus 4a plus 12. Okay, you can write it down, but don't set it up yet. What's different?
It's the 4th.
Okay, we did a 4th one earlier, didn't we? Or did we not?
There's
Maybe.
3. There's 3 variables.
They're all, is that all by 2?
Okay, honestly irrelevant. Sorry. Okay. It doesn't matter that it's a 4th, because remember I said I could give you 1 to the 12th and you'd be able to do it, right? Okay, so that's not a big deal. Let me put it like this. What's missing? Read the problem. What's missing? A cubed! There's no a cubed! Everything we've done so far has gone from the biggest exponent we've been given on down in order. This one doesn't have an a cubed. Alright, so here's how you handle that. Because yes, it does matter. Otherwise, it will throw your numbers off. Okay? So you see how we have 4a to the 4th plus 2a squared? You don't have an a cubed. You need to add in an a cubed without really adding in an a cubed. That's the trick. You got to add in an a cubed without really adding in an a cubed. Because it has to be there so we get our variables right at the end, but you can't just do something to a problem and have everything be okay. So what number can we put in front of a cubed that allows us to add it in without really adding it in? No. Yes. 0. Okay? So you got to change the question just a little bit. Okay, and this goes for if anything's missing. So you got 4a to the 4th plus 0, a to the 3rd plus 2a squared minus 4a plus 12 divided by a plus 2. Alright, and then you use those numbers. Okay, this is important. If anything's gone missing, you got to put a 0 in for it. Alright, so -2, 4, 0, 2, -4, and 12. The process, though, is the same. That never changes. Okay, bring the 4 down, multiply it by -2 to give you -8. Add it to 0, you get. Multiply by -2, you get. Add it to 2, you get. 18 times -2, you get. Too soon. Too soon. 18 times -2. Subtract 4 from that, you get. There you go. Times 2, -2, I mean. 80. 80 plus 12. 92. And 92 is your what? Your remainder. Okay. Now, we started with a to the what? Fourth. So this is going to be 4a to the third. All right. So just because the a to the third doesn't happen up here doesn't mean it's not happening in your answer. Okay. So we have 4a to the third minus 8a squared plus 18a minus, whoops, a little high, 40. Since 92 is positive, your sign before your remainder is plus. Your remainder itself over what you divided by, a plus 2. Now what's the 5.2 worksheet? That's on Schoology, okay? The one I showed you guys yesterday. All right.